Okay, so in this video, we're going to use logarithms to solve exponential equations. And I really think, to be honest, this is kind of the point of logarithms, right? Okay, it's for solving equations like the ones you're going to see here. Okay, so we're going to get exact answers in this first example. Let's start off with an exponential like this. 2 to the power of x is equal to 30. Now, apart from trial and error, you haven't really got a way of doing this until the logarithms came along. So what we're going to do is we are going to solve it first by base 2. So we're going to start with this equation and we're going to take logarithms of base 2 to both sides. Remember from that previous video, we said that logarithms were like an operation. You can act on an equation by doing the same thing to both sides. So that's got to be true. Now, the reason that I said the third law was the most important is because from here, we can solve the equation because we can bring the x down using that third law. And of course, what do I raise 2 by to get 2? Well, 1. So that means that kind of disappears and we have solved it, right? That is the answer. Now, log base 230, it's just a number. You could put it into your calculator if you wanted a decimal, but we were asked for exact values, so I'm going to leave it like that. Now, some calculators, the old ones, they won't work in base 2. They only have base 10, right? So that's why base 10 kind of is that default most important thing. Let's just have a look at how I'd solve this with base 10. Well, I'm going to start off with exactly the same thing. I'm just going to take logs of both sides. Remember, if it's base 10, you don't need to write that base. Okay, so from there, I can bring down the x. So x log 2 equals log 30. Now, log 2 and log 30, they're just numbers. So we can divide both sides by them. So if I write x as log of 30 over log of 2, I am finished. That's my answer. That's my exact value, right? Okay, log 30 over log 2. Now, there is a relationship, look, between log 230 and log 30 over log 2, which we're going to explore in the next video in our series, changing the base. But we'll come back to that soon. Right, let's have a look at some new stuff now, right? Okay, so we've got an interesting letter there, E, right? E is just a number. Now, we're going to look at that, okay, maybe in a future unit. But right now, just think of E like a 2, like a 7, like a pi, even better, right? Okay, the number pi, it's just a value. It's an irrational number, right? And if we have e to the anything, right? Okay, well, a log of base e is actually, so let's just say log base e of x, is actually written as the natural logarithm. We call it ln, okay? As I'm English and where I'm from, I just call it ln of x, right? Okay, or ln of x, right? So just a quick note there. So if I'm going to solve this equation, I'm going to take logs of both sides, but I'm going to use ln of x, right, on both sides. And you'll see, oh, excuse me. I'm going to have to say ln. Okay, so ln of e to the x equals ln of 30. Now I can bring the x outside, right? Okay, ln of e equals ln of 30. And of course, what is it I raise e by to get e? Just a 1, of course. It cancels itself out. So we're going to be just left like that. Okay, and you see, if I have anything to the power of x like that, like 2 to the power of x, and I take a log base 2, that is the inverse operation to raising to by, with a base of 2. It's going to cancel itself out for that exact reason. Okay, so there's my answer anyway, ln of 30. Let's take a quick look at part B. Now, to start with, we actually don't want to go and do anything until we've divided both sides by 3. So we can do that and write e to the power of x over 2 is equal to 7. At this stage, we can now take that natural logarithm from both sides. So ln of e to the x over 2 equals ln of 7. So at this point, we can just jump straight to x over 2 is equal to ln of 7. Well, I can multiply both sides by 2. X equals, 2 ln 7. And if I really want to, I'm not sure it's even appropriate, I could write ln 49. Do you know, on second thoughts, I'm going to leave my final answer as 2 ln of x. Okay, let's just move on and keep going, right? Okay, but let's have a look at something that looks a little different. Let's try and use that inverse law that we saw, right? Okay, so P is equal to 200 times 2 to the power of 0.04t. Let's rearrange this equation. Okay, so we're going to make T, the subject, right, in terms of P. So I'm going to start off by dividing, well, let's write it out. And then what we're going to do is we're going to divide both sides by 200. So P over 200 is 2 to the 0.04t. Okay, so what we're going to do now is we're going to take a log base 2 of both sides, and what that's going to do, it's going to undo this bit, right? Okay, just like what we were saying before. So if I take a log base 2 of P over 200, that is just going to be 0.04t. Okay, I mean, if you wanted to just write it and then see that third law and move it down and cancel out, you could, but you can take it from me. That is going to work out wonderfully for us. Okay, from here, we can just divide through by 0.04. So it doesn't look very nice, but do you know what? It's right. We're going to write that underneath 0.04. That is my expression for t. Okay, now find the value of t when p is equal to 6. So from here, part B, we're just going to input p equals 6. So log base 2 of 6 over 200, all divided by 0.04. Now you can do that on your calculators. It's going to come out, well, it's going to come out at approximately negative 126. Okay. Right, final question. Let's finish this with a really complicated question. So we're going to find algebraically the exact points of intersection of y equals e to the x minus 3 and y equals 1 minus 3e to the minus x. Okay, now I got no idea what they look like. I mean, I could probably work it out, but I don't want to because I know what to do here. I know they're going to be intersecting when one is equal to the other. So let's write that out. E to the x minus 3 is equal to 1 minus 3e to the minus x. Okay, so we've got to solve this very complicated expression. Now, I know some tricks that are going to help me here. I think I'm going to start off by pushing it all over to one side. So let's do that first. 3e to the minus x plus an e to the x minus 4 equals 0 is the first thing. And what I've done really there, I've just collected up the numbers, really. That's all there is to it. Okay, now, how on earth am I going to solve this equation without a calculator? Well, to be honest, I know some tricks, okay? And my problem is I can't do much with this. That's the problem. So what I'm going to do is I'm going to multiply both sides by e to the x. Now, what is that going to do? Well, the right-hand side is going to be fine. It's going to be 0 still, right? The minus 4 is going to be easy to work out. It's minus 4e to the x, of course. Now, what about my e to the x? Well, I know I could simplify it, but I'm just going to write e to the x squared for now, okay? And then let's just get that out of the way in case anyone's confused. Now, but what is interesting is what's going to happen to the 3e to the minus x, because let's just go over here a second. 3e to the minus x multiplied by e to the x, well, that's going to be 3 lots of e to the 0, because when I add the minus x to the x, because of the first law of exponents, I'm going to get that 0. Well, that's just going to be 3. So all I've got to write there is a 3. So my next line is this. Now, I don't know about you, but I'm getting quadratic vibes about this, okay? We could solve this like a quadratic because, I mean, I like to write a little substitution. Let's just make y equals to e to the x, and then let's rewrite this as y squared minus 4y plus 3 equals to 0, and now we can factorize it. Okay, so two numbers that multiply to make 3 and add to make negative 4. Well, that's going to be a minus 1 and a minus 3. So therefore, y equals 1 or y is equal to 3. But of course, we want e to the x, so we've got e to the x is equal to 1 or e to the x is equal to 3. Now, e to the x is equal to 1 is quite simple. Well, e to the 0 makes 1. Anything to the 0 is 1. So one solution is x is equal to 0. Now, for the other solution, of course, I'm going to take natural logarithms of both sides, right? So if I do that, and I'll write it out, even though I really need to stop doing this, okay? Because they're going to cancel, and we're just going to have ln of 3 right now. So those are my two x values. Now, if you go all the way back to the original question, we were looking to find the exact points of intersection. So I'm going to need some y values to go with that. Now, what we could use either one, but I'm going to use the easy one. I'm going to say use that. Y is equal to e to the x minus 3. Let's write that down. Y equals e to the x minus 3. So if I input the x equals 0, well, I'm going to have y is equal to e to the 0 minus 3, which is 1 minus 3, which is minus 2. So one solution, one intersection point is the coordinate 0 minus 2. Okay, what about if I input ln of 3? Well, if I do that, I'm going to have y is equal to e to the power of ln of 3 minus 3. And just like you've seen before, these are inverse operations, right? Logarithms and exponentials, okay? In this case, the natural logarithm and e, they're going to end up cancelling. We're going to be left with 3 minus 3, which is 0. So therefore, my other coordinate point is going to be ln of 3, 0. Okay, that last one was a very tricky one, but hopefully that's given you some understanding of how we can solve some different kinds of equations using logarithms.